I just wanted to share a quick analysis of what I did with the number sense 2 questions that I created that I had tested on some of my students to show you what I learned and what I didn't even know I would learn before I collected this data. So I had made 7 questions and I was just about to start decimal, so I thought, why don't I, give these to my students and see what happens. So I gave this to, I believe, 29 students. And what's kind of nice is I had their arithmetic score and their EAlgebra score as well. Okay, so if they got the question wrong, it's a 0. If they got it right, it's a 1. I have the sum, the total number of questions out of 7 they got right. And then I split them in categories. So category 1 is this green. They got 1 or 2 question right, so these are super low performing. 3 or 4 questions right is category 2, and 5 or 6 questions right is category 3. Okay. So then I did a regression. I wanted to see whether they got a question correct or incorrect. Does that tell us anything about what category they're in? So I'm kind of thinking, even though 5 out of 7 questions right, I'm not sure, if that would fall in the testing out or not testing out category, but I'm thinking they're kind of on the border. So I'm trying to see whether they got the question right. Does that tell us what category they're in? So then, let's see. So here's a correlation matrix. Just think of this as doing a linear regression on whether they got the question right as the input and their category as the output. So whether they fell in 1, 2, or 3. So of course these aren't linearly related exactly. The input is 0 and 1, so it's dichotomous, so we're not going to get some nice line, but we can see, well, as whether they answer the question correct increases, so comparing 0 and 1, does that increase their category? So here's the category down here, and these values down here are the p-values. So this tells you the probability that the correlation is just by chance. Okay, so this isn't causality, it's correlation, but we can still look at this. So less than 5% is kind of a rule of thumb for statistically significant, and notice these highlighted ones are all less than 0.05, whereas questions 1 and questions 5 weren't significantly correlated with what category they're in. So then I thought, well, why not? What's going on with questions 1 and questions 5? So I made some stack diagrams, and basically what this is I put, well, 0 is they got the question wrong, 1 is they got the question right, and I broke it down into those 3 categories. So 1 was low placing, medium placing, high placing. So these people got 1 or 2 questions right, this was 3 or 4, this was 5 or 6. So if you look at category 1, or question 1, the reason that this is problematic, notice that a lot of people got this right, barely anyone got it wrong, so it's not giving us a lot of information about category. And also notice there's some blue, red, and yellow in each, so we'd like them, a question would be quote-unquote better if all of the yellows were in here, or most of the yellows and the reds in here. Okay, of course that's not going to be exactly the case, but notice there's people from every category in each one. And a lot of people got it right. And if you're getting so many people getting a question right, it's not giving you information about where they're placing. So here was 2. 2 was a good question, and I like the way this looks. About equal amounts got it right and wrong, and notice most of the people who got it wrong, all of the 1s, about half of the 2s. Question 3. This was significant, and looking at this, we have the 3s and 2s. Only 3s and 2s got this correct, all of the 1s got this incorrect. So this is telling us something. 4 was significant. Notice a lot of people got this one wrong, so that may worry us a little bit. But the people who got this right are in categories 3 and 2. Now 5 was the one that was a bad question, and looking at this stack diagram you can see why. So look how there's blue, reds, and yellows in each category, or in each question response, right or wrong. So this isn't telling us anything about what category they're in. So this was actually an ordering decimals question. So this tells us despite your skill level, you're just as likely to be good or bad at ordering decimals. So that tells us something pedagogically, but not really about placing them into the test. So that's what I found as far as not wanting to probably use questions 1 and 5, though I'd still like to test them with a larger sample. And one last thing, let me just scroll through this. Okay, I also did a regression analysis and found the variables that we'd like to use to predict categories. So what if we used 5 questions instead of 7? We could even pick 3 or 4 and get a lot of information that we got from the 7 questions. I won't go into that into great detail. And this was something else that I found interesting since I had their arithmetic scores and their EALG scores. I wanted to see if their category score was correlated. Did I use category regression? If their category score was correlated with their arithmetic score, EALG score. And notice these were decimal questions, so this is arithmetic, and it was significantly correlated with 0.539, and that's not super high, but that's decent. And it made me happy that they were correlated, because that in a slight way kind of validates our instrument, saying that because it's correlated with this one that we know is nationally normed. Very little correlation between the EALG and the category, but then it was also interesting that the eAlgebra and the arithmetic scores weren't significantly correlated either. So that gives us other information, specifically for students who test into arithmetic. You can't really predict their algebra skills from their arithmetic skills either. Let's see. This was just a chart that I made. The regression score I used, I created a regression score that used those 5 questions. Okay, so it's from the 7-question test, but this just uses 5 questions. This was the original category 1. They all still placed low at 10. Category 2, actually this is blue, so this is category 1 people and 2 people, so this was their score. This 25 would be category 2 or 3 people. So I kind of broke these into 3 groups. So low performing, mid performing, high performing. And this might be a cutoff score. You know, maybe around here we want to accelerate, or we'd want to look at this more carefully, but I kind of like that there was a dip here. So you could kind of say these are high achieving and these are, you know, need more remediation. And that's the basic gist.